Let's talk about the errors in computer networks. So there are two kinds of errors. When you are sending a packet, basically why there will be errors is one thing is the entire packet will be lost. So packet loss is very condition is a condition which is not very rare. It is it is possible. The reason is only reason for the packet loss is congestion. So when you are sending, let us say there is a router, and when you are sending many packets to the router, or when many packets are being sent to the router, sometimes what happens is the entire buffer of the router gets filled and the processor is not able to process the packet so fast. Then in that case the packets will be dropped, and that is one reason why the packets will be lost. And other reason is, other reason for errors is, you will be able to receive the packet, but inside the packet either one bit or more bits will get corrupted, right? So the reason for this kind of errors is, maybe while the packet is being transmitted on the channel, there will be disturbance from in the external environment like thunderbolt or any frequency changes, because of which some part of the packet will get corrupted, right? So which means there is either a burst error means some few number of bits got corrupted, or there could be sometimes only a single bit error because of a small voltage fluctuation. So whatever it is, whenever the packet is lost, we are able to know it. There are various methods like acknowledgements, and we have seen that collision detection and all, and we could say that the packet is lost and we could ask for the retransmission. But the other case is, when the packet is received, how can you be sure that all the bits inside the packet are correct? So there is a chance that some of the bits might have got corrupted. Then how are we going to handle it? So this is nothing but error handling. So I'm not going to talk about packet loss. Packet loss will be handled by the other protocols we have seen till now. But then we are going to talk about the bit losses, which means whenever a bit gets corrupted, then what is that we are going to do with that that bit or a few bits. These are error handling methods. Error handling is, traditionally it has been of two types in data communications. One is error detection. Error detection means we know that some part of the data has been corrupted, and we only know that the packet is having some corrupted bits, and we don't know which part of the packet is corrupted or which bit got corrupted. See, in case if you know which bit got corrupted, you would correct it also, right? But error detection says that we only know that the packet got corrupted and we don't know where the corruption is. Okay, and the other method is error correcting methods. Error correcting methods say that we know that there is some error in the packet, and we even know where the error is, which means we have the capability to self-correct the packet, right? So these are the two mechanisms. Now in case if you find out that there is a error in the packet, and if you are not able to correct it, then only one solution is there. What is it? You have to ask for retransmission, right? And coming to error correction methods, in case if you find out that there is a error in the packet, and even if you can find out the location of the error, you need not ask for retransmission, you will correct the packet yourself, right? So in this case, retransmissions are required. Retransmissions means you should ask the sender to resend the packet, because you came to know that there are some errors in the packet, right? Now coming to these error detection methods, one popular or one most important method is the simple one. Maybe you might have even seen this. So when you are typing when you are creating any account in Gmail or any other website, they'll ask you one thing: type the password, right? Enter the password, and again they will ask you re-enter the password. Why? The reason is, when you are typing the password for the first time, you must be having some password in your mind, and you might have typed some password here, because you will not be able to see it, right? It will be all in dots. Now then if there is a mismatch in the password in your mind and the password which you typed, if they directly put it in their database, then what happens is, later when you try to re-enter the password and log in onto the website, you will never be able to do it, because the password you remembered is different from the password which you typed. Now in order to catch it, if they again ask you to type the same password which is in your mind, there is no less probability that you might type it wrong 2 times, right? Now what happens is, let us say you have typed it wrong first time and you have typed it right next time. Then what will they ask? Are they going to take your second password as the valid password, or they are going to ask you to retype both of them? They are going to ask you to retype both of them, right? Why? Because they don't know whether the first copy is right or the second copy is right. Therefore you have to do the same again. Now the same method can be applied here. So send the data once and send the same data second time. If the first copy of data compared with second copy, if they both are different, in case if both the copies are different, then you can easily find out that one of the copy got corrupted, but then you will not know which copy, either the first copy or second copy. Then what should you do? In this case, you are detecting that there is an error and you should ask for retransmission, right? And the problem with this method is, if you have to send 1 million packets, right, you are sending 1 million plus 1 million, 2 million packets, which means the data is going to be double, the traffic is going to be double, all the devices, networking devices have to be doubled, right? But then the error condition is, out of 1 million, only one packet will generally the error condition is 1 in 1 million, which means the bits will get corrupted only in one packet if you are sending 1 million packets in practice, right? So for that 1 in 1 million packets, you are going to send 1 million packets again in order to just protect one packet. Obviously this method is not used practically. This method can be used, if you are trying to save some, in RAID techniques you might have seen this. This is one of the levels of RAID techniques inside your computer, in computer organization, right? So next method is parity checking. Parity checking is, either you carry, you must be knowing about it well. Either you count the number of zeros or number of ones, and you try to make either number of ones as even or number of ones as odd. Now when you are sending this in this way, if there is a change in one of the bit, then the bit count, finally it will not agree, because you are trying to make it as odd or even, but then it will be a different number. So parity checking is not very powerful, but then it is in practice for a long time, and there are various versions of it. One is vertical parity checking and other is horizontal parity checking, and there are various ways you could play with this parity checking. And then the third method is CRC, cyclic redundancy check, and fourth method is checksum. So these are the various methods, various popular methods, even though we have many more, but these are the popular ones. Coming to error correcting methods, first thing is Hamming code. So about Hamming code, I'll discuss it in algorithms course. We have Hamming codes in algorithms, and even we have a Hamming code in digital too. So I'll either discuss in algorithms or digital. But what you should understand here is, coming to this Hamming codes, if I have to send a data of 1 KB, I have to add 0.5 KB, half KB extra redundant data. That is the disadvantage, and moreover it takes lot of time to compute the computationally it is going to take a lot of time. So one disadvantage is, if I have to send 1 KB, I have to send half KB extra data which is redundant, which means if I have to send 1 million packets, I have to send half million extra packets. This is all redundant and this is all useless, isn't it? Why to send half million packets if 1 million packet is going to be sufficient? So this is the disadvantage. Disadvantage is, I have to send half million extra packets just to find out the error in 1 million packet. Therefore in practice, in computer networks, coming to computer networks, we are never going to use Hamming codes. So in computer networks, we are going to use, one is CRC and other is checksum. These two are most popularly used methods in computer networks, and Hamming code is rarely used. Hamming code is never used in computer networks. The reason is, one is computationally infeasible and second is lots of amount of extra data, right? So now we shall see what CRC is and what checksum is. Okay. I'll explain CRC with an example. CRC, where first C means cyclic, and R means redundancy. C means check. Okay. So why is it called cyclic redundancy check is, first of all, we are going to use something called as cyclic codes. So since we are going to use cyclic codes, it is called cyclic. What are cyclic codes? I'll discuss it in digital because it requires a lot of number system analysis. And next one is redundancy. Redundancy means we are going to have the actual data to which I am going to add some redundant amount of bits. That is why it is called redundancy. And loss check. So check means the receiver is going to check whatever you have sent. That is why it is called cyclic redundancy check, right? Cyclic means it is cyclic code, redundancy means we are going to add extra bits, and finally receiver is going to check whatever you have sent. Therefore it is called cyclic redundancy check. I'll take an example and I'll show you. Let us assume that there is a sender and there is a receiver. Okay, this is happening at the sender side, and there is a receiver. Sender has to send some data to receiver, and the data is 101111, something like this, simple data. In practice, no, we have KBs and MBs of data, but for this example, just keep it simple. Assume that this is the data, which means 7 bits of data is there, and both as sender and receiver will know a common number called as CRC generator. So assume that CRC generator is 4 bits, and this is the CRC generator. CRC generator 1101. Then what will sender and receiver do is, sender at the sender side, it will compute the CRC using this CRC generator. Now if the CRC generator is 4 bits, understand this, if the CRC generator is 4 bits, we are going to add 3 zeros at the end, which means we are going to append 3 zeros. Why? If CRC generator is 4 bits. In case if the CRC generator is 5 bits, we add 4 zeros. In case if the CRC generator is n bits, we are going to add n minus 1 zeros, right? And this is 3 bits is the CRC we are going to get. Now we are going to apply exclusive ORing. So before going to this, I'll just discuss about exclusive OR, represented by this symbol called exclusive OR. So exclusive OR is also called as modulo 2 sum. So what is modulo 2 sum is, you add the numbers and divide it with 2 and find out the remainder. That is called modulo 2 sum. If I have 1 and if I want to find out 1 exclusive OR 1, then the result is add both of them and divide it with 2 and take the remainder. If I add 1 plus 1, I get a result of 2. And what is the remainder of 2 when divided with 2? It is 0. 1 exclusive OR 0. Then it is 1. 0 exclusive OR 1. Then it is 1. 0 exclusive OR 0. It is 0, right? Why? You just add them and take the remainder after dividing with 2. So if I have 1 1 1, if I apply exclusive OR, what will be the output? 1 1 1 is nothing but 3, and 3 when divided with 2 is, remainder is 1. 1 0 1, if we add 1 0 1, what is the output? 1 plus 1 is 2, and 2 when divided with 2 is, remainder is 0. And 1 0 0, what is the output? 1. Why? Because sum is 1 and remainder is 1, right? So now I am going to use this exclusive OR in order to find out the CRC. So CRC generator is 1101 and the input is this. Now I want to find out the CRC. So how we could do it is 1101, I'm applying the exclusive OR. If I apply 1 and 1 exclusive OR, it is going to be 0, and this one 1 1 1 0 1 1 1 is 0, okay, and you write the remaining number 0 1 1 0 0 0 0 1 1 1 2 3, right? Always start again from the leading one. So leading one is this, right? So start again applying the exclusive OR from this point using the CRC generator, which means 1 1 0 1. Then what do I get? 1 next to 0 or 1 is 0, 1 next to 0 or 1 is 0, 0 0 is 0, 0 1 is 1, and this is 1 1 0 0 0. Then again you apply it from the leading one. Leading one is here 1 1 0 1. Then what do we get? 1 x to 0 or 1 is 0, 1 x to 0 or 1 is 0, 1 1 is 1 0 is 1, 1 0 is 1, and then 0 0. 1 1 0 1. Again one more time, right? So it is 0 0 0 1, right? Now if you try to apply from the leading one, you will not be able to apply it, therefore you have to stop here. See, when should you stop is from the leading one. If you count the number of bits, there should be at least 4 bits. If you have anything less than that, you have to stop the procedure. From the leading one, there is only 1 bit, therefore you have to stop it. After stopping it, the least significant 3 bits is going to be CRC. Why only 3 bits? Because CRC generator is 4 bits. So if CRC generator is 4 bits, CRC is always 3 bits. If CRC generator is n bits, then CRC is n minus 1 bits. So in this case, since the CRC generator is 4 bits, CRC is 3 bits. So these 3 zeros which you have appended are going to be replaced with 0 0 1, and this will be the CRC along with the data that will be transmitted, which means the data that will be transmitted to the receiver side is actual data, which is 1 0 1 1 0 1 1. Along with it 3 bits are appended. So what are the 3 appended bits? 0 0 1 0 0 1. So this part is CRC and this part is actual data that is being transmitted. Now what will receiver do is, receiver will check if the data that is transmitted is right or wrong, which means if there are any errors or it is fine. So for that it is going to use the same method. 1011 is the CRC generator. See, remember, CRC generator is well known to both sender and receiver. It is not used for cryptography, therefore you need not keep it secret. It is actually known to both the parties, and both the parties will apply it to find the CRC. Now again it is going to be applied 1101. What do we get? 0 1 1 0, and write the remaining bits. 0 1 1 0 0 1 1 1 0 1. So what is it? 0 0 0 1 1 1 0 0 1, right? And again write from the leading bit. So leading bit is this, leading one is this from here, 1 1 0 1. Then what do you get? 0 0 1 1 0 1. Again from the leading, 1 1 0 1. Then what do you get? 0 0 0 0, right? So if the data with the CRC is right, which means if there is no error in the data, then the CRC you get will be zeros. If you get all zeros as CRC, then the receiver will be sure that there is no error in the data. Let us assume that you are sending the data and there is some error in the data. Then what happens? So let us say this is the entire data that has to be transmitted, and because of some error, some bit got corrupted. So say this bit, the third bit, instead of 0 1, it got corrupted to 1, which means the receiver got a error corrupted packet, and the packet is 1 0 0 1 0 1 1 0 0 1. So we got a mistake here, right? So this bit got corrupted. This is supposed to be 1, but now it changed to 0. Then what happens because of this? What is the problem because of this? See it. CRC generator is 1101. Then I am applying CRC again. This is all happening at the receiver side. 1101. So if you exclude your 1 and 1, it is going to be 0 1 0 0. Okay, I am simply applying the exclusive OR only. Write down the remaining bits 0 1 1 0 0 1, and again start from the leading one. Leading one is here 1 1 0 1. Okay, now apply exclusive OR again, which means 0 1 0 1 1 1 0 0 1. Again start from the leading one, 1 1 0 1. Then what is it? 0 1 1 0 1 0 0 1 1 1 0 1. Then what is it? 0 0 0 0 0 0 1. Right? Now you have to stop it here, because from the leading one the number of bits are not 4, there is only one bit. Therefore the CRC we got is 3, which means the final answer we got is not zeros. So you should not call it a CRC, but I know I'm just saying that. So the remainder is not 0. Therefore we can say that something went wrong in the question. But then the problem is we don't know what went wrong. Okay, so CRC will be able to detect the error, but it will not be able to correct the error. Let's see what are the various ways in which CRC will be given and input will be given, and how to compute it now. Okay.